live button, I could just kind of.
Well, I just pressed the go live button, so that may have been the start of that episode right there. We are live on the show. Welcome everyone to CoinWatch. This is a segment that I host with Paul Puey. He is, of course, the CEO of Edge. Welcome to the show, Paul.
Thanks a whole lot for having me, Naomi. It's been a few weeks. We've both been traveling, but glad to come back together and host another episode and cover another couple of coins that many people love and hate. And so that's just part of the cryptocurrency world.
Absolutely. So today we are talking about Ethereum and we are talking about BSV. Now, both of these have been surrounded by controversy recently. We just had some conferences where Ethereum was really the highlight, and a lot of people then took to the internet to say Ethereum is vaporware, it is a scam, it is everything bad about the world. So we're going to talk a little bit about that. We're going to talk about the promises that Ethereum developers have made in the past, made during the launch, where they've come in that, some of the scaling issues that they face, but also some of the interesting solutions that they're proposing. I think there's a lot of interesting stuff going on there. So we'll kind of dive into the good and the bad there. And then we're going to also discuss BSV. Now, this is not something that I usually discuss on my show. Paul, I'm going to blame you for this one. I mean,
sure, it was all my fault. I put it as one of the choices, but the community voted on it.
The community voted. They absolutely did. Yeah, so I mean, I'm of the opinion that I'm just a disclaimer. Anyone who watches my show knows that I'm not a BSV fan for a lot of reasons. So I'll just go right out and say that. But Paul, you have some really interesting things to say about that. And I'm glad that you're here to talk about it, because what I don't want is just to avoid things because I don't like it. I still think it's really helpful to discuss projects and talk about the good and the bad in things. Sometimes there's a lot more bad than good in certain projects, but I think it's really nice to just have an atmosphere to discuss this stuff. So I really appreciate you taking the time out. And you have this really interesting perspective on the entire crypto ecosystem. And I brought this up on previous shows, but you're in this unique position where you deal with all kinds of coins. I mean, Edge Wallet supports a whole bunch of coins. And in order to do that, you have to really understand in depth how a lot of these projects work. And so it provides this very unique perspective. You're not necessarily a developer that is specific to one coin. And so you know that in depth, and you don't have much of an understanding about anything else. You're someone who has to have an overview of every coin. So that's really helpful in a show like this, where we can compare coins and you don't really have, a particular stake, mind the pun, in any one project over the other. So thank you so much once again for coming on the show to chat about all this.
Yeah, no, it's always helpful to be able to honestly, actually, even though we've covered a bunch of different coins, a lot of what this show does actually forces me to kind of really go and deep dive into some of them, maybe a bit more than we already know at the level that we interface with them. And so it's great to be able to both share the knowledge that we already have with a lot of the viewership, and as well kind of learn a bit as well from deep diving into it on our own.
Absolutely. And I'll also say right off the bat that I hate the word scam. I used to find that to be a useful word until everyone started using it to refer to any project that they didn't like. And so now I just hate that word. And it's unfortunate because I think it's an important word. And I think it's a word that we need to use in this space because there are a lot of scammers. But I think that what this episode tries to provide is a conversation that actually talks about what's actually going on and doesn't just dismiss something and call it a scam and leave the conversation at that. Let's dive into things. Exactly. Let's really, take that deep dive, as we like to say in this show. So let's get started. I want to start with Ethereum. Yep. Now, there are a bunch of things that we could go on into with Ethereum. What I will just say right off the bat is, they've been plagued with some pretty severe scaling issues, but this is not unlike a lot of what the rest of the crypto ecosystem is facing, especially if we want more and more people to come into the space. It is difficult to facilitate that, and there are always trade-offs when you try to do so. So Ethereum has come up with a bunch of different solutions that they trying to use to help this, and one of the ongoing jokes is that they just keep pushing it back. Like, it's always 2 years out, and so there are some interesting developments that they're working on, though, and I would love to go into detail about what some of these things are. So first of all, just walk us through an overview of what Ethereum is to you.
What exactly is? Exactly.
What is it to you, Paul?
well, what is it? What is it at all? What is it to
Yeah.
anyone? And I think one thing that I credit Ethereum for is if you look at the cryptocurrency landscape prior to Ethereum, we did have many coins. It wasn't just Bitcoin. It was Bitcoin, Litecoin, Namecoin. If you looked at the top 10 cryptocurrencies by market cap back before Ethereum, you saw a bunch of coins which were basically Bitcoin forks. Ethereum was one of the few currencies that really created something different. Whether you love it or hate it, think it can work, or you think it's a scam, it notably created something different. And I think we noticed a launch of a plethora of protocol different coins after Ethereum. And so kind of winding back into its early times, it was one of the first ICOs on any platform. We actually saw ICOs even early before Ethereum existed, but it itself, in and of itself, was one of the first ICOs, which happened in between July and August of 2014. And at the time was a huge amount of money raised about $18 million worth of Bitcoin. I'm sorry, at the time, I think since the Ethereum didn't exist, it was raised in Bitcoin and other payment mechanisms. And that was through the sale of about 6 million Ethereum. So obviously they sold it at, pennies on the dollar relative to its price today. And, went in hard work on development, and about a year later launched mainnet in July of 2015. And that saw, obviously, as we are aware, the plethora of ICOs that happened, starting with, admittedly, a very respectable project with Augur that happened, I believe in 2016 I believe about 2016. But the notable difference about Ethereum that makes it significantly different than anything that came before it was, as many people have heard, its programmability. And not to discredit Bitcoin and its programmability, but to give you one of the fundamental kind of core differences between kind of Bitcoin before Ethereum and then Ethereum itself is Bitcoin's programmability really allowed you to have fairly simplified statements that said, if this, then that, and if this, then spend the money. That's really all you could do, is you could put money into an address and then create rules by which the money could be spent. You say that if you had 2 signatures, if you provided a secret value, if the time, if there was a certain time that you were spending the money after, so it's a time lock value, if those conditions are met, or a subset of those conditions are met, then the money could be spent. But that was pretty much it. It was pretty binary. Could the money be spent or not? That was what the programmability of Bitcoin had. Ethereum took that and expanded it into what you may have heard as the buzzword, a Turing complete language. It allowed you to have arbitrary if, then, else. And not only could you just spend the money, you could then spend a certain amount of the money. How much of the money could you spend? As well, you could send it to specific addresses. So under certain conditions, you could send money to an address, you could send a larger amount of money to a different address, you could write data onto the blockchain, just arbitrary data. You could read data out from the blockchain, and that could be inputs into your program. And so that flexibility has created what we see today as kind of this DeFi movement, which now allows us to not just replace the financial system of money with a decentralized alternative, but it now allows us to replace financial services on top of that money with a decentralized alternative, such as the lending and borrowing of funds, which we see through projects like Maker and Compound, which we're very excited about. A lot of the industry is excited about. But of course, as you
one thing that I would jump in here to mention is sort of the atmosphere around when Ethereum was first created. And I think it's helpful, especially for people who came into the space later. I mean, they're just kind of reading the articles that are coming out now, hearing how Ethereum is talked about now. So I remember going to a conference at the start of 2014 and watching this presentation from Vitalik, and no one really knew who this kid was. And he's like invented this new language, serpent, and everyone's kind of like, well, what's going on here? And there was this groundswell. There was this buzz around this word Ethereum. Everyone's talking about it. It was pervasive. Like that's my recollection of it, and it was like everyone was calling Ethereum Bitcoin 2.0. So it's kind of funny that now Ethereum's talking about Ethereum 2.0, and we'll talk about that in a second. But it was like everyone at the time, as you said, this was like the next thing. Bitcoin kind of got money down, and then Ethereum was going to come along, and this was this programmable money that could do all these other things, and not just money, but we had smart contracts, we had like all these interesting things, and it was like this It was this really interesting. So this like it started 2014, as you said. This is like over a year before Ethereum launched, and so there's like this build up. And so when you say that Ethereum launched, and the price at the time was just like nothing compared to what it is today. But like it's not like this thing happened and no one knew about it, and then suddenly it got big. It's like everyone was talking about it. I felt in the build up, and I think it's just helpful to kind of contextualize that and then to see what happened, because I mean, Ethereum's kind of become this centerpiece, like whether you love it or hate it, or think that it's useless, or think it's creating vaporware or an enabling tech for bad actors, whatever, it has become this centerpiece of the crypto community. I think it's important to talk about that, especially because through the ICO boom of 2017, everyone was using Ethereum tokens as like they had their proxy tokens before they released their coins, or they were releasing coins as ERC20 tokens, and that was the end game. And it's really interesting to see Ethereum kind of come in and do that, and also look at the journey of how Vitalik got there, because he didn't come out of nowhere and just say, I'm going to create Ethereum. Like, he wanted all this stuff to go onto Bitcoin.
He did, actually. And he was a pervasive writer on Bitcoin Magazine, actually one of the founders of Bitcoin Magazine in and of itself, and published some of the best articles as describing the Bitcoin protocol. I know one of the articles he had written was very educational for me on the effect of quantum computing on Bitcoin and the hashing algorithm that Satoshi had decided to use for public addresses. Now, interesting, you had mentioned how Ethereum was used throughout the ICO boom and the tokenization of assets, or just the launching of tokens. Now, looking back, actually, tokenization on Bitcoin was actually one of the big key motivators for Vitalik to launch Ethereum. He'd actually had multiple conversations with the colored coins projects that were on Bitcoin and talked about, how could we make this much easier to do on Bitcoin? So unfortunately with Bitcoin, one of the reasons why it didn't get widely used for tokens is that there were multiple competing protocols. There was the Colored Coins project, of which there were several that were incompatible, and there was Mastercoin and Counterparty. And it's like, well, which token protocol do you effectively use if you wanted to launch a token on Bitcoin? And so the lack of standards is actually one of the challenges that Bitcoin had from the viewpoint of tokenization. Whether or not you like tokenization or not, it's just, if you wanted to launch a token, there were multiple standards, and wallets didn't know which one to choose, and you had very poor support. Right out of the gate, as soon as Ethereum was launched, because of its wide programmability, there could have been multiple standards as well. There easily could have been. But one of the first ERCs, or Ethereum requests for comment proposals, was ERC20, which created a standard by which you create tokens. And also because of its programmability, it was fairly simple to do. And that in and of itself, I could almost anchor, if you had to put a lot of Ethereum success anchored on something, it was the fact that they made a very simple and very standardized system for creating tokens, which a lot of the dApps then anchored on, for good and bad, for shitty ICOs that just raised a bunch of money for no good reason, as well as legitimate projects that have a dApp that need their own token to protect their security model. But tokenization is an anchor of why it was built, and to a strong degree, why it achieved some initial success.
Yeah, and so it kind of makes me question. I mean, when you have these, I mentioned these conferences that have just been. One of them was Devcon, and there was kind of this moment where Joseph Lubin, he gets up on stage and he actually concedes, like, we knew it wasn't going to be scalable for sure. Something, a protocol that is created around the idea that this is going to be used for everyone to build on, and now they're saying, well, we knew it was going to be scalable. And I think it's also interesting to put this into perspective, because I think people saw scalability as this thing that, we'll figure it out. We, like, a lot of people kind of jumped into this, and Bitcoin as well kind of jumped into it saying, well, this is what we have the capacity to handle right now, but tech will get better. We'll figure this out. Once the people come, we'll have the tools to make it work. Like, what are your thoughts on this? And then let's move into some of the solutions that the Ethereum developers are coming up with to handle scalability.
So admittedly, I would say that most technology, especially anything that's kind of on the bleeding edge, simply can't afford to think very early on about scalability. Ironically, it sounds terrible. It's like, oh my God, you haven't even factored in whether or not your product will scale. If you're building a fairly conventional product, you're building the next Uber, that technology is built for you. You know you're going to be able to scale. Maybe you don't use the tech right away, but you know it's available for you. When you're building out something that's completely new era of technology, yeah, you don't know that. And in a way, you can't really let that hinder your innovation. If you try to make it scalable from day one, you'll just never get there.
Well,
right?
that's one of the key tenets. That's one of the key tenets that people in Silicon Valley and VCs tell you, is when you're creating a product, start by doing things that don't scale. That's how you're going to get your consumer base. That's actually something that they teach people, and later on you won't be able to do those things, but they say at the start, do things that won't scale. It's it's interesting that
it's kind of true. It's because what is, if you had just even basically like an Uber app or a Facebook app, what are the things you do to scale? You launch hundreds of different servers and split your data between multiple different databases and split out your images from the text and all that stuff. Are you going to do that if you're just starting off? No, you're going to host it on a single server sitting on Amazon AWS and just get a few hundred users to try it all out, and then figure out scaling after the fact. Fortunately for that type of use case, you at least have the solutions laid out for you because other companies have built it. Right. In the case of blockchains, you're building out something completely different and you just don't know what it's going to look like at scale. So you do have to put some factor into it, but you can't think that you've got it solved right from the get-go. There's no way. And you know that over time, you're going to have to look at what challenges arose from scale, from people using, more people, millions of people using the product, and then tackle those problems, because you don't just scale. Scaling is not a linear thing, like not scalable to scalable. Scaling is, well, look at all the different angles by which your product isn't scaling. Is it memory? Is it bandwidth? Is it CPU horsepower? All of those things, and then figure out which one is the bottleneck and then scale that. And you won't really know that until you actually achieve a large amount of adoption. And so that I think is the thing that people would criticize projects like Ethereum for. It's like, oh, you already knew it wouldn't scale, but you kind of know that on any young project, and you then try to figure it out over time. And then the question is, what path do you take to actually solve it?
So what path is Ethereum taking? They're talking about Ethereum 2.0, and they've been talking about moving to this proof of stake model for a long time now. Ethereum 2.0, it seems to be this thing that incorporates a whole bunch of different tools. So, we've got Raiden Network, Plasma, Caspar, sharding. These are all proposed scaling solutions, and they're trying to, make this hybrid with all of them? Walk us through some of these things.
So, to kind of just take a step back into what does it mean to solve scaling, or what does it even mean when something is more scalable? The piece that a lot of people forget is, what exactly is the bottleneck that you're hitting? And so in the case of Bitcoin, we ask, well, what are the scaling limits of Bitcoin? Why can't we have nodes process every single transaction? And why do we want to get onto layer 2, blah, blah, blah? Well, it comes down to just really resources and how you use those resources. So for example, every time you publish a transaction, nodes have to validate that the transaction is correct. It's not double spending. Well, that's CPU resources in and of itself. And every node, so you've got 1,000 nodes, you're now taking one transaction, multiplying it by 1,000 times, and that's 1,000 times the CPU horsepower needed to validate one transaction as if you had just one node. Second, you have to store that transaction. So there's a storage bottleneck there, right? And next, you now have a bandwidth limitation. So that one transaction has to propagate to all of the different nodes on the network. And ironically, the more nodes you have, the more bandwidth you need, because you're actually taking up more bandwidth on the internet. The fewer nodes, if you had one node, there's no bandwidth necessary. It just holds it and it doesn't broadcast to anyone else. So the more nodes, the more bandwidth you need. So looking at Ethereum, one of its biggest challenges in scaling versus Bitcoin is that a transaction in Bitcoin, the computational power to validate a transaction is fairly well known. It's simply check the signature of that private key, check the fact that the source funds are there, right? Where it's spending from, source funds are actually there. But that's really it. Now there's more complicated versions of that. I'm kind of oversimplifying it, but it's kind of at its gist, it's that. With Ethereum, with a fairly complicated program that can loop and jump, read data, write data, you now have the potential for a single transaction to look like something on Bitcoin that's 1,000 transactions in size. So one of the biggest hurdles now is the computational power of the network. And now with one transaction having to be done on thousands of nodes, you're no longer scaling well because you're not able to split up that work, right? You're taking what could be a simple operation one simple transaction on Ethereum would be simple on my computer, but now having to do it on thousands of computers is fairly expensive. And then now having to do it for millions of people becomes untenable altogether. So with respect to scaling, we're seeing a small handful of buckets of scaling ideas. Number one, put it on a different chain altogether. Right? We kind of call it poor man's sharding. Don't use Ethereum, use Tron, use this one, but use a bunch of different chains altogether, and you just have to convert money using Shapeshift or Changely back and forth. And so one app is on one chain, one app is on another. So I call that totally poor man's sharding.
And that that decreases the security, right? Because if you're going to just split the network up into a bunch of different coins, then you have less hash power protecting those.
Yeah, exactly. You have less hash power protecting each one of them, which ironically could be somewhat said of side chains as well. But you have less hash power protecting each one of them. You also have some aspect of trust to go from one chain to another, right? Even if that is, if that is like a change layer, or Shapeshift, or an exchange to go from one asset to another, you do have some aspect of trust. So, but that's kind of like your one angle is, let's split it up across multiple chains, whether that's side chains, which is a lower level of trust, or fully different mainnet chains, which is somewhat of a higher level of trust and more inconvenient from a user experience level. Second to that, we're seeing layer 2 networks payment channels, where you're taking the same asset, you're not putting it into another chain, but you're layering on top of that a mechanism of moving the asset and then settling onto the main chain. So we see that in both Bitcoin as the Lightning network, and then on Ethereum as Raiden. So the protocols are actually quite similar. So if you hear that term Raiden, you can kind of think, oh, this is effectively the Lightning network, but on Ethereum. And it's able to transact specifically ERC20 tokens. So the Lightning network on Bitcoin isn't at all right now designed with any protocol in it to transfer any tokens. It's really just designed to transfer Bitcoin. Raiden is just designed to transfer any token on Ethereum. So those have been kind of the two things. And the good thing about each one of those is they actually solve that CPU problem, that processing problem, in the sense that all the nodes don't have to process every single transaction. If it's a side chain or another chain, only the nodes of that chain are processing the transaction. And if it's off-chain layer 2, then only the channel operators for that specific transaction, the people that are running channel nodes from the source to the destination, only they are processing the transaction. And then you could aggregate that together and settle on chain, hundreds of transactions settled on chain with one transaction that all of the nodes process. The problem with each of these is what I would call user experience. Admittedly, this is probably the one flaw of the poor man sharding, using, it's use Litecoin, then Bitcoin Cash, and BSV, then Ethereum, the poor man sharding. And then the layer 2 payment channel solutions, such as Raiden and Lightning Network, have the user experience of, I have to go and take my Bitcoin and then lock it into a channel, or take my Ether and lock it into a channel. And that channel has a certain amount of inbound and outbound liquidity. And then I have to route it, and that route may be there or may not be there. So it's not invisible to the user. It's not just, I have Ether and I just send it to someone else. And this is what I think I give credit to the Ethereum team for doing, is they're looking for a scaling solution that's invisible to the user. Like, the user just has ETH and it just tries to send ETH and you receive it. So it feels the same. And so how they've implemented this is with a combination of, and so they have the what I call the kind of poor user experience solutions with side chains, which is the Plasma project, and then state channels, kind of like Lightning, which is the Raiden project. But ETH 2.0 primarily encompasses a move to proof of stake and sharding. So not the poor man's sharding, but the kind of the automatic sharding, where I have a transaction, I send it, it's just received on the other side. How that's implemented, though, is kind of the nitty-gritty details that we can talk about real quick if you'd like. Shall we?
Absolutely. Yeah, well, I want to talk about Caspar. I want to talk about this giant shift that we've been waiting for a long time.
Right.
And I also want to talk about some of the interesting aspects of Ethereum. Like, I mean, inflation is a really interesting aspect of Ethereum, and they deal with this in a much different way to other chains. Inflation, the inflation schedule.
No, exactly.
Just
That is very different.
having a predetermined inflation schedule, having that shiftable, you know, I think that's what turned a lot of people off, but it's also something that Ethereum users really say, no, this is necessary for our network. So I'd love to kind of delve into that. But let's talk about Casper, let's talk about proof of stake, and then wanted to move over to this purely proof of stake model. Because there's like, and my understanding is that you know, Vitalik does want this purely proof of stake model. And and at the moment, they're still kind of talking about a hybrid model because they are worried. I mean, I would presume that people would try to keep the other Ethereum chain alive. I mean, the same way that they've kept Ethereum Classic alive. And he doesn't want that to happen. So having some sort of a hybrid where they actually don't split off into two chains, but instead try to incorporate all this into the one chain is what they're looking at. But maybe you can explain that a little more.
So the hybrid, to the best of my understanding, is a transitional phase where they're going from kind of ETH 1.0 to ETH 2.0. But at its heart, ETH 2.0 at its design is meant to be entirely proof of stake. And this goes very hand in hand with its migration to sharding. So I think really sharding is at the heart of the shift. It's also at the heart of scalability. A lot of people think proof of stake is a solution to scaling. And I'll put my foot down right now and tell you right now, proof of stake is not a scaling solution. Period.
Oh, you just put your foot down. Those really
proof of stake is not a scaling solution all by itself. Because even if you have proof of stake, if you do everything else the same, every node still has to validate a transaction, every node has to store the transaction, every node has to compute and has to broadcast the transaction. So you haven't actually solved scaling. What you have done though with proof of stake is you've made finality faster. So instead of 10-minute blocks, you can have 3-second validation. That's a very different value proposition than actual scaling. So it's not that it's not valuable, it just doesn't solve scaling all by itself. However, sharding does. Sharding makes it so that you have a subset of nodes that validate a subset of transactions. So let's take this Ethereum 2.0 architecture and kind of go into it a little bit more detail. What they're effectively doing is taking, instead of one Ethereum mainnet chain, you're taking it and starting up to multiple chains. And you could segment those chains, as an example, by breaking them off into 100 different chains. Each one of them could be how they've decided to which transaction goes into which one. I haven't dived into deeply, but one proposal would simply be take the start of your address, your contract address, the address that you have money on, and based on the starting few digits, you get assigned into one of the chains. That would be one sharding proposal mechanism. And
well, so they are looking at it being randomized, right? And I'm not sure.
That in a way is a random.
What randomized process they're going to use.
Correct. So a public address is random. So by using the first few digits of a public address, that is one way that you could shard which balances and which transactions go to which chain. So just say that you have an address that starts with AZ. Well, you now are in, it can't start with an AZ because that's not a hex, so AF. The AF, that goes into one of the chains. Now what you then have is proof of stake validators that look at multiple chains, but not all 100 chains. If there were 100, they look at maybe 2 to 4 chains. And they validate transactions only on those chains. And they can verify that if funds are transferred from one chain to another, that the source funds are effectively destroyed on one chain and then reappear on another. Now, if you're only transferring funds between the same chain, then the validator only needs to validate transactions on that chain. But as soon as you cross chains, you then have to solicit validators that happen to be looking at those specific 2 chains for the transaction of value. But you don't have to affect potentially the 98 other chains. Simple as that. So the validators that aren't touching those 2 chains effectively don't have to do any validation at all. This is what's creating that sharding of that CPU and memory and processing power that you don't have with a regular blockchain, pretty much all the blockchains that we've seen today. And the interesting thing is that the validators inherently now need to be on proof of stake. And so proof of stake is a necessity because what proof of stake does, this is a very interesting thing, is proof of stake makes it so that the protocol can control which chains the validators have to validate. It can randomize. You said it's randomized, right? Well, what's randomized is which chains you as a validator are going to validate. And it can rotate that every so often. It says, okay, you've staked enough Ether. You're going to validate chains 98 and 57. Okay, well, the next time around, after some amount of time block, you're going to validate 36 and 21. And this prevents a validator from being able to game the system by choosing which chains he wants to validate, which he might know a transaction is going to happen on. So that randomization can happen in proof of stake because the protocol can control the miners, right? A validator is kind of a miner. The protocol can control, hey, I want you to validate these specific chains. You can't do that with proof of work. With proof of work, the energy is in the physical world, it's real. You can't control where that energy is applied. Someone can just simply shift their energy to whichever chains they want to actually mine. So it's actually fundamentally important that they move to proof of stake in order to achieve this control over the validators, where the protocol kind of wags the dog. The protocol says, you go here, you go there, you go here, you go there, you go here, you go there. And in proof of work, the protocol can't do that. The miners choose which chain they want to mine on anywhere in the world. And so this is a core fundamental piece of ETH 2.0 and why these two go hand in hand, this concept of proof of stake as well as the sharding.
Absolutely. That's really helpful to piece those two pieces together. And I appreciate that. And I mean, there are other things to go into with ETH as well. And you've kind of lumped a few of them together. But before we move on to BSV, I do just want to mention inflation in Ethereum.
Yes.
And how that works. I mean, it's really complicated. If you were to look up, like, what is the inflation schedule of Ethereum, it's really hard to find a definitive answer that takes into account everything going on in the ecosystem, where it's headed. You know, it's not the static thing that we're used to, like in Bitcoin, where we have this predetermined inflation schedule and we know when the last Bitcoin's ever going to be mined, etc. So walk us through how it works on Ethereum.
So in Ethereum, let's go from the very founding. So the very founding had the pre-sale, right, which raised funds, the ICO for kind of the Ethereum Foundation. That was a 60 million Ether crowd sale. From there, they also allocated 12 million to the developer fund. So this is money that went into creating apps and creating the protocol, creating implementations, full node implementations, of which they actually funded more than one full node implementation, which is a stark contrast to other coins. So they already had decentralization of the developer base at mind when they did that. And then after that, the inflation schedule is about not to exceed 18 million Ether a year, which sounds a lot when you think about the fact that it was 60 million for the pre-sale, 12 million for the dev fund, that's 72 million. And out of the 72 million, you're saying 18 million a year? Well, it sounds like a lot, but realize that as your supply increases over time, 18 million becomes a very small amount, right? It's at max 18 million. So that amount gets smaller and smaller and smaller of the rough percentage of the total. So if you take it as an absolute amount, yeah, it sounds like a lot, but if you look at it as the percentage of the total, it trends towards zero to the point where it becomes an insignificant amount. That's, I think, an important thing to understand, is that, yes, it does have infinite inflation, but how meaningful is infinite relative to the total if it's small, tiny fractions of the total amount that's circulating in the economy, especially when you compare it to the inflation that we see in the fiat world. It becomes
right. Oh, well, I mean, gosh, that's comparing apples to oranges there.
It's almost apples to oranges, but ironically, a lot of people will say that. It goes, oh, why have dollars, right? They both infinitely inflate. But we know the inflation schedule, and we know that it will trend towards zero versus it just being kind of arbitrary and usually larger in later years than in earlier years.
Well, let's talk about why. I mean, a lot of people go to the default, and I'm sometimes one of those people who's like, well, inflation is always bad. You know, it's this is pejorative that Austrian economists throw out. It's like terrible. I'm kind of on that bandwagon, but it's not as simple as that. It's a nuanced argument, because you have things like, you know, developer fees that people are trying to figure out how to make the system sustainable. Ethereum is something completely different. You know, they're talking about this not necessarily as this currency, but more as this fuel for the crypto economy, which is a different way of conceptualizing it. And I think it's helpful to look at it with that nuance rather than thinking of it as this currency that keeps inflating. So talk a little bit about how they have talked about inflation as this fuel.
So inflation being a fuel versus the currency being a fuel. So admittedly, yes, the currency of Ethereum was marketed as being the fuel to drive the smart contracts. Like, it wasn't to be a currency for payments, for value transfer, for store value. It was meant to be the fuel to create the smart contract. Although ironically, I think that rhetoric is changing. especially as we're seeing the DeFi movement where you're taking Ethereum and you're staking it into these smart contracts that are now backing loans. Now that it actually becomes an asset in and of itself as opposed to a fuel to drive the smart contract. But from the viewpoint of inflation being a fuel, this is actually important from the viewpoint of what motivates validators in the proof of stake world or what motivates miners in the proof of work world. And this is probably a hotly debated topic in Bitcoin, is what happens when there is no more Bitcoin mined? Do we have enough financial incentive for the miners to actually mine transactions so that they put a lot of energy into mining and therefore provide a lot of security? By having an infinite inflation, you know that there's at least something that's going to help motivate people to mine or validate the currency. And if it's not that, then it becomes the transaction fees that they would be collecting. And it's a balance between those two. Really, miners care about the total reward, the fees, and what they receive from inflation. And if one goes down, the other one has to go up. That inherently is kind of the fuel of the system, or it's securing the system by having this infinite inflation schedule. And while, I kind of sit with you as well, and I agree that I don't like this concept of inflation, I think it's been given too negative of a view in the cryptocurrency world, whereas really what's negative is this arbitrary, controlled by a small number of people inflation schedule. That's what we've associated with the term inflation, versus just the fact that an asset can grow in supply, but if it's fixed and known and you can account for it, that may be a very acceptable economic model that can work.
Yeah, I think that, as you mentioned, the main difference there is that one of them is a very opaque system where it's this group of elites that we don't even vote in get to make these decisions that just affect all of us like so directly in our day-to-day lives. And we have these TARP bailouts. We don't even know where that money went to in 2008. Yeah. It's completely opaque. We can't audit the Fed. They try over and over again, and politicians just block that. So it's this very opaque system where we don't know how much money is being created, where that money is going to, who's receiving it. On the other side of things, it's a very open system where you can see that. So I think there's a big difference there. I understand why people take pause at the word inflation, but it also seems like in Ethereum, you just have to look at it with this nuanced understanding. Is there anything else you wanted to mention about Ethereum? Because I don't want to take up too much time here. I want to move on to BSV because we got a lot to cover there and we don't have too much time.
I think we covered quite a bit on Ether, so yeah.
We've got a lot on Ether there. And maybe I'll try to summarize some of these and put out a video that just takes the Paul Puey highlights so that people can check that out and get the essence of this. So let's go to BSV right now. And I don't even know how to start.
No one's going to have a hard time here.
I am. It's like I've gotten so much hate already. And that's from the BSV supporters. It's like, I can't win on this show. If I don't cover BSV, they're like, she's closed-minded. She's terrible. I do cover BSV. They're like, she's manipulative. She doesn't like us anyway. She'll only say bad things. I'm very honest with the fact that I don't think highly of the BSV tech. That being said, I do have a lot of friends who are working with BSV. They do like it. I disagree with some of the reasons why they like it. But I think that it's useful to approach their arguments with an open mind and just discuss them openly. And I know that you have this perspective where, you don't want to shut down anything right off the bat, and you want to look at innovation happening. And I would agree with you there. I love seeing innovation in whatever form. If people are trying out new cool things, then I think that's beneficial for everyone. So with that, me being very generous there, I want to look at some of the things BSV is trying out, and maybe you can help guide that conversation there. So walk me through like BSV, the history of how this came about, all of that.
Now, where did BSV come out of in the first place? And so ironically, we haven't talked about Bitcoin Cash yet. And so if we had, we can kind of use that as a foundation. But just saying, yes, BSV was a fork of Bitcoin Cash, and it came from a disagreement on a few changes that were being proposed on the Bitcoin Cash chain. Ironically, one of the things that fascinates me about the existence of BSV is that it's one of the few forks that we've seen in this ecosystem where there was no inherent mandatory replay protection, which means that at the time and the date and the block that BSV forked from BCH, it didn't really fork from it. It was BCH split into two, and really the community didn't know which one was BCH. It was what I call the ugly, bloody, but fair battle for the name BCH.
I have to say that this was one of the most exciting things to happen in crypto, right? And I say this because we talk about this like 51% attack, and how if you don't like it, you could just split off and do all the, like, we talk about that, but we actually saw this for really the first time play out, where you had one chain specifically saying that they will attack the other, and orphan blocks, and I think that it was just really interesting to see this mechanism play out.
Yeah, it proved how this Satoshi consensus mechanism really works, and who are the deciding factors. Like, is it the miners? Is it the nodes? Is it the people? Is it the exchanges? Is it the entire ecosystem? I think what I got out of it was it's kind of a little of everything, and each player in the system affects the others, in the sense that people that are allowed say, no, we want this chain to be BCH. Well, that affects the wallet providers, and what do they call BCH? And that affects the exchanges. But then what the exchanges decide affects the people who are able to buy the token, and what they're able to buy affects the price, and then the price affects the miners, right? It's this big circular loop of influence between all the players in the ecosystem. But what came out of it in the end was the BCH ABC chain was able to retain the ticker symbol and the name and all of the kind of ecosystem that worked with BCH. And then what then became the BSV chain kind of semi-started from scratch and had to build out ecosystems. Some platforms admittedly said, no, we are a BSV app and we're not going to support BCH. But by and large, most of the ecosystem that supported BCH ended up supporting the kind of ABC side, and they then had to build out support for BSV. So that applied to many exchanges. That applied to us at Edge. We had to add support for BSV into the application to support it. And so this showed a true kind of battle and how kind of winners are determined. And part of my theory is I think this has not happened to BTC yet, and that it potentially might still happen where there's an internal struggle. That's a whole nother discussion.
Well, I think just on that note, I do want to mention the lead up to this split, and something that's very interesting that I think maybe a lot of people don't realize, and I'm about to say something controversial that you may or may not agree with. I would say that, a lot of people look at BCH and they see it as this other end of the spectrum to BTC. I would say that BTC and BCH are a lot closer together, and BSV is the other end of the spectrum. And what we saw during the initial talks, where like before Bitcoin Cash was created, you saw basically there were these people who wanted different changes, and you started to see that divergence there. And then there were people who believed in these really large blocks. And the people, now the BCHs, didn't really speak out against this. And in hindsight, this may have been a mistake, but you got to, not create too many enemies at once. And so you sort of saw this unholy coalition of people who weren't necessarily on the same side go off and say, okay, well, we'll go off to Bitcoin Cash then. And now what we've seen is they've split again, and that alliance just didn't end up working out, and all the big blockers really have gone off to BSV. So if this had happened at the time and they split into three coins right then, I think it would be a very different environment, because the people in BCH really do have quite a different understanding of what Bitcoin security is and what's necessarily in the ecosystem than the BSV people do.
Definitely. It does feel like, and I've talked to a number of the people in BCH camp, that they're looking at actual limitations of current today hardware and costs of operating that hardware, and what effect that has on the centralization or decentralization of nodes and mining and whatnot, and try to factor that into the decision of, well, how big do the blocks get, and how big can they get. Now, admittedly, one of the core arguments from the kind of big blockers back when BTC was just one coin, right? There was no fork, was that there was a natural decision within miners. I think Peter Risen put out this study and paper himself. This is, I think, either right after BCH forked or beforehand. He said that miners themselves create their own block limit, right? And you can actually see it over time. But back when Bitcoin, it was the only kind of chain, it had a 1 meg block limit. But before it hit 1 meg, you saw that miners would create these limits at, say, 200K. 300K, 400K, and you'll see many blocks hit that limit and nothing exceed it for some period of time until they suddenly they suddenly internally deemed that, hey, their hard work could handle it. As well, there was a demand for a higher level, and then it would up. And it would up in these notable chunks. So it's almost like there was a block limit, and it was just being elevated over time by the miners, all within the 1 megabyte chunk.
And I think that's interesting to talk about why they did that, Paul, because there's a security element of that. And there's this idea of spamming the network that, you know, if you're seeing that there's a consistent rise in transactions, then you know that, okay, we'll go with that. And that allows the miners to increase their soft cap as you go. If you just say, okay, no soft caps, let's just leave it open, what you end up happening is these spikes happen throughout the network of spamming, and these attacks can happen. And that actually puts the people who are running the infrastructure, running the wallets and running the mining equipment, all of this, it puts them at risk, because the infrastructure, you know, if they're used to something else, it may not have the capacity to handle all of these spikes and everything that's happening.
So it does have the potential for the spikes, but what describing by Peter Risen's paper was that even with a 1 megabyte block, the miners were already implementing limits below that, well below that, and transactions weren't exceeding a certain size, blocks weren't exceeding a certain size. So my argument here, in a way, you know, not that I'm a huge supporter of gigantic blocks, is the argument is that the block size may be less relevant than we think. That yes, we have 128 meg blocks, but if the ecosystem simply says, sure, that's just the number coded in code, but that doesn't mean I have to allow block sizes that big. And I can choose to actually throw away solutions to blocks that I think are too big and allow miners with smaller blocks to come in. As well, there's a motivation in mining smaller blocks anyway because of the propagation issue.
Right? What would happen with a miner who increased their block size to something astronomical, and they were like, well, I'm just going to allow this 1 terabyte block. And then all of the other miners, the full nodes would then have to accept that to validate it. Like, I mean, does that create issues?
Not necessarily. A miner can actually simply choose to not accept that block and not mine on top of it. The main thing is you accept the block when you start mining on top of it. But for you to mine on top of it, you have to verify it. You got this gigantic 1 terabyte block. You could simply say, you know what? It's going to cost me a tremendous amount of energy to verify this block. It's going to cost my neighbor a tremendous amount of energy to mine this block. Why don't I just mine on the previous one that was small? And I'm going to hope that someone else publishes a block that's smaller before someone else mines on top of this gigantic one. And so there is at one point a trade-off in saying, I'm just going to risk not mining on top of this gigantic block, but I think that that's a good risk because I don't have to verify it, and someone else probably won't like it either. And that's what was happening when blocks were 1 megabyte in size. Miners were effectively doing that, but in smaller block chunks at the 100K level, the 200K level, 300K level. And they could be doing that even at the 128 megabyte level. They could be doing that at 4, 8, 16, 32 megs. Now, the reason why it's not happening in BSV is because the community is very proud of its size. Like, they're not saying, hey, this is basically no limit, but let's let miners choose. Instead, they're actually trying to push it to that limit and put anything that they possibly can onto the blockchain to say, hey, it's okay to have 128 megs. Whereas in a more healthy ecosystem where the miners actually have this motivation to say, no, I don't want to publish that block because I could orphan it and lose money, of which that actually has happened. We've actually seen an instance where we had a 6 block reorg because a miner mined 128 meg block and it took forever to propagate, and effectively you had a chain split because other nodes couldn't validate it. Well, that miner lost money. They legitimately lost money. And so I think it's what is the goal of this of the people contributing to the network? Is it to prove that 120 megs is possible? Well, then yeah, they'll do irrational things. Or is it to prove that it's okay to have a very high limit because you'll end up using smaller ones to get there as time proceeds? And so I'm not opposed to the limit being 128. I think I'm opposed to trying to prove that that's an okay limit today.
Right. And let's talk a little bit about the essence of BSV. My understanding is that they really want to, I mean, their focus is on this metanet right now.
Yeah.
You could talk about what the metanet is, and they basically want permanent data on the blockchain, and their idea is basically replacing the internet infrastructure as we know it now and putting information on the blockchain instead. And so it's like this really interesting it's this interesting situation that I think is a terrible idea, and maybe you have a different opinion there. So I mean, and I also wanted to maybe I'll bring that up in a second. I have another point about that. But this seems to create a lot of issues when you want to put all of this data on the blockchain, because there seems to be this centralizing force that happens there. But I'll leave it to you to first just explain how all of this works.
So ironically, we've heard this before. We heard this in the big 2017 ICO boom off Ethereum. All of these apps launched and said, oh my God, we're going to take this and put it on the blockchain. We're going to do dating and put it on the blockchain. We're going to do X, Y, and Z, put it on the blockchain. And I am not the type of person to say that all use cases are a scam if they're on the blockchain, but I don't think that the blockchain is going to replace the internet. You're not going to take every single application put on the blockchain. It'll give you a case in point example of why. In the metanet protocol, it states that it's going to do user permissions in a few different ways. It's going to require signatures to authenticate access to the data. Actually, no, it's going to authenticate ownership of the data, and permission to write onto the blockchain is based on your signature. That makes sense, but it's going to control permissions via encryption, meaning you encrypt data onto a public blockchain to control permissions. Now ask yourself this question: how are you going to put all of the internet on the blockchain just via those rules? How do you then create an app like a Facebook that has permissions for a photo that I post on Facebook that allows my friends to see it, but not the subset of friends who I deem, not family, or my family, because, it's my Vegas picture, so I don't want my family to see them. But I want to let the second degree friends of my friends see it. And oh, by the way, if I unfriend someone, suddenly all of their friends can't see it. Basically, permission access or access control of data is incredibly hard using encryption, which is why we don't do access control with very complex rules via encryption. We do it through a server that basically is the gatekeeper. And it knows who are the users that can access, what groups can access, and it just says you have access or you don't. Yes, that is a more centralized way of doing things, but it's also a more scalable way of doing access control. Access control by encryption is untenable at scale. So that in and of itself proves that there are some use cases that simply don't work on a public blockchain. Doesn't mean there can't be, and I think the creation of the metanet protocol isn't necessarily a bad idea, but to state that it's trying to take the internet and put it on chain is definitely too ambitious of a goal that I don't fundamentally think is ever going to be achieved. But making a protocol by which you can write data and you can create apps that then can read that data, sure, there's actually a lot of flexibility that can be had, just like we see on Ethereum that allows you to write data and read data. You can put encrypted data, and you can create conditions under which you can execute and write data. That's entirely fine. But the proposal of what to use it for, I think, is at the heart of the issue is really how much of the internet can you put onto the blockchain? I don't think you can put all of it. And in fact, you can put a small subset of it.
And let's talk about how much information that would be. So it's 8 exabytes per day of data that's created on the internet. And right. If you think about who has the capacity to store this information, Google can't handle 8 exabytes of data a day. Facebook can't handle 8 exabytes of data a day. So what you're like, if you're hoping to replace web servers with the blockchain, which is what the BSV stated goal is, like what would it take? You would need to have a company that is larger than Google and Facebook combined. And they would basically be this repository of information, this very centralized system. I mean, you look at, I mean, there are better systems like that already out there. I mean, IPFS is this really interesting system that's a lot more decentralized than that. And it strikes me as this absurd goal that they're aiming for now. Like as I said before, I love innovation. I love trying new things. Yeah, let's see what kind of use cases can come out of the blockchain. But I think if you're thinking about 8 exabytes of data a day, and somewhere in your head that seems like a reasonable thing that could be achieved, I think it's kind of delusional.
Ironically, it could be reasonable, but only if they made significantly large changes to the protocol itself to actually implement something like sharding. Obviously 8 exabytes a day, but sharded across many, many different entities, that we can handle because that's what the internet already does. And the internet is inherently sharded.
But they don't want to do that because, again, they want to keep the
correct
Bitcoin as, Bitcoin 1.0, the original version that was ever created. So, I mean,
that is the challenge. Yeah, it doesn't make a lot of sense. That's probably what I would put in front of a lot of the BSV supporters and Enchain, is that, hey, this concept of making this layer to do more than just payments on the blockchain, that's fine. It opens up innovation. It's a protocol that people can use. It's a good standard by which they write and read data off the blockchain. But really propose what you think are the limitations for the applications to run on that, as opposed to anything on the internet. Propose what you think is reasonable, give good examples of what you think is reasonable. And if you really think you can replace a lot of the internet, be realistic with how you're then going to scale the chain. And are you going to implement some aspect of sharding to do that? If that's not on the roadmap, then realistically, yes, at 8 exabytes of data per day is going to be untenable for nodes on the network. Even one, you'd have less than one node at that point in time, because you'd end up having 5 companies become one node. So admittedly, that is both the criticism, but also, for those that are supporting this level of, flexibility on a blockchain, consider it a challenge. Like, really try to solve that as a challenge. And to me, I see it as fair experimentation. So I don't overly criticize this, but it's like, hey, go ahead and try to solve those problems legitimately if you think that that's what can happen on the chain, versus just sweeping it under the rug and saying, oh, it's fine, we can do it.
Oh, it's fine.
We can just replace the internet. If you want to replace it, actually put some hard numbers at it and find how to solve those problems.
Yeah, yep, for sure. And one thing I will just mention in terms of that inconsistency there, and I promised myself that I wouldn't bring up his name. In fact, I'm going to say this without bringing up his name. So let's talk about what Satoshi Nakamoto has said in the past about the blockchain and what information should be stored in there, because I think that's important, especially when you're dealing with a coin that is putting itself out there as saying, we are Satoshi's vision, we are exactly what he wanted from this, we're creating the metanet, that's what he wanted all along, which is the rhetoric that we're hearing at the moment. So Satoshi has said, when we're talking about Namecoin, like a long time ago, so Namecoin was this interesting creation that basically they would have used DNS resolution through the blockchain. And so what Satoshi actually wrote, like when Satoshi was still active, he wrote that you don't want to bloat the blockchain with unnecessary data. If you want to do that, go and create a different coin, which is why Namecoin came around, because they wanted to do all of this on Bitcoin. And he said, it doesn't make sense to have data stored that doesn't have anything to do with financial transactions. These are quotes from, that I paraphrased, from Satoshi Nakamoto when he was still active. And now the BSV people are saying, this is Satoshi's vision. There should be a single blockchain that does everything. This was always the intent. So there seems to be a big inconsistency there.
Maybe it's the fact that there's many Satoshis that created Bitcoin, and one more disagrees with another.
Sure, I'll give them the benefit of the doubt there.
And some might argue that, and I know that from the viewpoint of a lot of the core camp, they say nothing but an actual transaction that sends this X amount of money should be on the chain. One might argue that even though, like when you put a protocol such as Mastercoin or Counterparty on top of Bitcoin, and a lot of supporters of that theory that, yes, this is not a financial transaction, it's not sending any Bitcoin, you're just sending a little bit of dust, and therefore it should go onto some other chain. But one might argue, but that transaction that's only sending a dust amount of Bitcoin is still transacting some value. It's just a different value than Bitcoin. It's some token, it's some tokenization of a real asset. It's still some kind of value. And in a way, if you're building financial applications using this metanet, and you are using this data layer to store something that's relative to a financial transaction, that could be argued as still achieving what, and Satoshi said, is that you're putting data relevant to money on there. But admittedly, if you're putting tweets, weather data, which apparently right now is the vast majority of data being written onto the BSV blockchain, is basically a copy of weather data from a centralized service, then you're not quite achieving, those comments that Satoshi had mentioned. But admittedly, I do like the fact that, that the group sees an expansion of what data can be stored on there, because that data might be implementing some smart contract functionality, which is implementing a financial service. And that I think is still valuable, even if you're only sending dust's amount of the native currency to implement that. I think that's still potentially important.
we are running out of time here, so we'll start to wrap things up now. But one thing that I will mention, I mean, and I'd love your thoughts just before we close up, is even if we're not talking about replacing the entire internet, or I shouldn't say replacing the entire internet, I should say like, even if you're planning on putting all of this data on the blockchain, data from the entire internet, right? Even if we don't get there and the aim is just to put a bunch of data on the blockchain, I would love to look at some of the issues that have already come about from this. So you already have miners trying to prune transaction. You have node operators who are pruning. There are all these things that are going on where people are saying, well, I don't want to host child porn that is now on the BSV blockchain. I want to get rid of this data because it costs money to store. It's more difficult to store this. But the problem is that if everyone does this, I mean, you need someone to store and serve up this child porn, right, so that new nodes can be set up, right? So the problem is that if everyone prunes all of this data that they're saying is the whole reason, for BSV that we want this permanent record of data, but if you have everyone pruning this data, then you can't bootstrap new nodes, right?
Correct.
So you need the full blockchain in order to get a new node up and running, and you can't have that if everyone's deleting the information on there. So this seems like an issue already that we have with BSV, where there's too much data on there and people just don't want to deal with it.
Yeah, that's going to be an ongoing problem as the data just gets bigger and bigger and bigger. Admittedly, you don't need very many nodes to hold the full blockchain. You need nodes to hold basically the UTXO set, basically the unspent transactions. And ironically, the first thing that actually is prunable are what are called the op returns, which is the data storage layer of a transaction. Those are the easiest to prune because they're not inherently necessary in determining inputs and outputs. But by deleting that, you're actually deleting the use case of using the chain as a data storage layer. So the easiest thing to prune, the thing that most nodes can prune, is the stuff that you're basing the philosophy of this immutable data store on a blockchain. But inherently it becomes mutable because if there's too much data, people will want to prune it and will.
Right.
Exactly.
It's this interesting issue. There's also, I mean, you have this rhetoric about BSV people saying that, well, only the miners should be running nodes, and this is sort of the direction that they seem to be going in there. And that again seems inconsistent. The whole idea with Bitcoin, it was designed so that we could replace trust with cryptographic proof, right? And now it seems that this mantra that only miners should run nodes seems to replace cryptographic proof with trust. You've got to trust the miners to do that. There's no one validating these things. No one wants to run a full node because it's just too much data. And so you're starting to put your trust more and more in these centralized areas there. And when I say miners, I mean, at the moment, it's all N-chain, right? It's all of the miners is Craig Wright and Calvin Ayre. So I have a lot of issues there, but I will, as you mentioned, give the benefit of the doubt there that I'm interested in innovation. If they can solve these problems, that would be really interesting. At the moment, I see huge inconsistencies that make me interested in this, but I will keep following everything in the space as I always do. And I really appreciate you just kind of providing this open discussion about everything that's going on, because generally the discussion comes from people who are like 100% in the camp or 100% not in the camp. And when that happens, you just don't get anywhere.
You don't have a good discussion.
You don't. So I really appreciate your perspective.
So there's definitely stuff that I disagree with in the entire development of the project, but then stuff that I see as promising if they can at least maybe admit to limitations and also try to solve them. I think if you do that, then you've got some promising progress and protocols being developed. But there's definitely quite a bit of issues, and I see it as what I call a very experimental chain, but I'm open to experimentation, but I definitely wouldn't put a tremendous amount of value on it right now until some of the challenges are kind of at least admitted or solved.
Paul Puey, always the diplomat there. I really appreciate your time. I appreciate all the wisdom you bring to the table. Ethereum, BSV, if you guys haven't checked out this segment before, I think so far we've covered Dash, Monero, Litecoin, and XRP. So go check out those episodes. But Paul, you always just bring it's such a delightful conversation as well, but just so much insight as well. So thank you so much for joining me. Guys, check out Edge Wallet. He is, of course, the CEO of Edge. This is a sponsored episode. I just really like Paul, and I think that he's very open-minded and fair. So he comes on the show to talk about things. But in return, check out his products because they're really, really cool and easy to use. So everyone in the chat, thank you so much for being here. Paul, thank you so much for being here and chatting. You guys have a wonderful rest of your day, and we'll catch you all later.
Thanks for having me. Take care.
See ya. Da, da, da.